What is the difference between sequences and series? In everyday life, these two words are often used interchangeably, but in mathematics, they mean very different things. Let's look at sequences first. So a sequence is just an infinite list of numbers. For example, 1/2, 1/3, 1/4, and etc. What about finite list of numbers? Is it a sequence? Yes, we can actually make it, any finite list we can augment with trailing zeros, and then it will become a sequence. Okay, now, so what do we mean by series? Let's look at the following example. Suppose you're opening a bank account, and when you get a statement from the bank, it typically lists your transaction amounts as well as the balance after each transaction. So let's look more closely at what this means. So the transaction amounts are just positive or negative numbers, depending on whether you are depositing or withdrawing money. Now, the balance that the bank computes, that's simply the algebraic sum of all your preceding transactions. So, for instance, on this picture, let's say on September 7, after you deposit $150, your new balance will be the sum of all deposits you made by that day, which is 500, 200, and 150. So that's amounts to the total 850. And you do it every day. So you do it for every transaction. So for example, on September 12th, you withdraw money, so you subtract $350. So your balance decreases. Now, here's the terminology. Like in accounting, this way of track your balances after each transactions is called recording the running total. Why is it called running? Because it's not just a single total. It's a total after each transaction. Okay. And in mathematics, we call each running total like this a partial sum. The sum of the first several transaction amounts. So we have a sequence of partial sums. And the list of balances that is generated, we call the series. Okay. So the series is simply a sequence of partial sums. In other ways, it is a running total. Okay, now let's look more closely how we specify sequences in mathematics. Elements of sequence are usually enumerated with integers. For example, a1 equals square root of 1, a2 equals square root of 2, etc. We say that the sequence has a general formula ai equals square root of I. This formula relates the index I to the output value square root of I. So think about the general formula as a function whose input is integers, positive integers, and the output is whatever output values you have for the sequence. Okay. Now, what is a partial sum? So if you have a sequence A1, A2, A3, and so on, the nth partial sum is simply the sum of the first n terms of the sequence. For example, suppose you have a sequence 2, 4, 6, 8, 10, and so on. The fourth partial sum of the sequence will be just the sum of the first 4 terms. 2 plus 4 plus 6 plus 8 equal to 20. Sometimes people use so-called sigma notation for writing a partial sum. So rather than write A0 plus A1 plus so on plus AN, people write this Greek letter sigma, which is a summation sign. And then you indicate that your index of summation runs from 1 to n. And when do we use a notation like this? Usually it is when your sequence uses a very complicated long formula for like the general formula. In that case, it's more compact to write the sigma notation. Now, here is one cool thing. The bank, when bank computes your balance after a new transaction, it's not going to add all your previous transactions. That would be a waste of time. It takes your previous total and just updates it. It adds the most recent transaction amount. So that's what we have here. So the sum of the first n plus 1 terms in a sequence is equal to the sum of the first n terms of the sequence plus n plus first term. In other words, the n plus first partial sum is nth partial sum plus a n plus 1. So let's look at our bank example again. So you open the balance. Your so your balance is $500. On September 3, you make a deposit $200, and your new balance is the previous balance plus this $200. So it's $700. On September 7, you make a new deposit $150. So you take your previous balance $700 and add $150. You get $850, and so on. So you see, we don't have to add all your transaction amounts explicitly. We just update the running total. If all you know is your running total, you know, the series of balances, you can always figure out the transaction amount on a specific day. The transaction amount will be simply a difference of your balance after the transaction minus the balance after the previous transaction. Okay. So, for example, suppose all you know about some sequence is like a few partial sums. S3 equal 20, S4 equal 35, and S6 equal 57. What can you say about your original sequences, the sequence AN. Let's see. Well, we know the third partial sum and we know the fourth partial sum. So from here we can figure out the transaction amount between 3 and 4. In other words, we can figure out the fourth term of our sequence. So it's just the difference of two running totals, which is 35 minus 20. It's 15. Also, since we know S4 and S6, the difference of these two running totals will give you the sum of the transactions which happened in between. In other words, it will tell you A5 plus A6. Okay,